Watch this closely. No internet, no API key, no server anywhere. What you're watching is Meta's Llama 3.2, a real large language model running entirely on this phone. It's reading raw menstrual cycle telemetry like cycle lengths, flow data, or anything that you want for your app, and it's streaming back structured health insights privately offline. In this video, I'm going to show you how I built this in Flutter using the package Flutter Local Agent Kit, how I installed everything, and how I made it work. So yeah, without further ado, let's get started. Quick context on why I went on device. The standard AI feature that we integrate in apps usually go like this. The user data goes to cloud API, and the API analyzes the data and then returns back with the output, and from app side we have to show the data. So it cannot go offline, it has to be done all online. So for that reason, I just wanted to try out how offline looks like and how these local LLMs work. Do they work faster? And do they actually work fully offline? Now, why I chose menstrual data as an example for this project, because I personally felt that the menstrual data is something that should be kept private. It should be kept offline, and the data shouldn't be used by anyone. No third party should be using it. And for that reason, I came up with this idea and I thought I'll implement it. Normally, why you would choose a local LLM over an API, I would think of these three reasons. First is privacy. If you are planning to make an app that is privacy focused, I would suggest you to go for a local LLM because you don't have to worry about anything that's related with privacy. Everything is local. It is on the user's phone. Second is, if you're thinking of the cost, the local LLM basically doesn't cost you anything. Once you have installed it in the user's device, it will work with whatever knowledge it has and it will continue working for free. And the third reason would be if you want to go completely offline. So you can use local LLM for creating apps that you want to make it work completely offline, but at the same time it would have some AI characteristics. Now you do have to make sure that local LLMs, they are well tested by you, because they have been trained with certain data, right? And if you want it to work for you, maybe you would also have to fine tune it a little bit. So it totally depends on how you do it. But once you reach to a point where, okay, it's good to go, then you are in a great position to add it in the user's phone. Now, from where did I get this model? Basically, in Hugging Face, you can get a list of models. I did go through some research on which model will be best for menstrual data, and AI came up with this answer that, Llama 3.2 1B Q4KM would be the best decision, because that is very small compared to other LLMs and it has a very precise answer compared to other LLMs of small size. So for that reason, I went for this. But again, like, you can analyze and according to your data requirements and find the right model for your app. Now let's quickly jump into the project and see how we are going to integrate this LLM. The first thing is we are going to integrate the package called Flutter Local Agent Kit, which I've mentioned earlier. Right now I'm using the version 1.1.5. And once you have selected the model that you want to install from the Hugging Face, once that is done, you copy that and add it in your assets folder. I have added under assets/models folder, and I renamed it to something that's more readable, because the file that they give, normally it's pretty long and it doesn't make sense. So I renamed it to mylocalmodel.gguf. So GGUF is a file format for the model. Now once that is done, we are going to quickly call the Flutter local package kit. So we are going to create an instance of that, and then we're going to get the LLM model file so that we can use it in our project. In order to do so, there are like two ways, but for me the first way didn't work for some reason, so I went for the second way. The first way is directly referencing the model from the assets folder. And the second way is to actually install it in the user's device and get the file from there. So I tried the first one, pretty simple, but it didn't work for some reason. It was not able to find the file for some reason. So for that reason, I went for the second one, which is getting the application documents directory from the phone. Once I did that, the app was able to find the file and it was able to use it. Now once that is done, we have to initialize this kit with the path that we have just figured out. So just make sure that you are able to find the path and the model does not create any error that it's not able to find the path. Okay, once that is done, we just set up the model path, the GPU layers, and the context size. Basically, GPU layers is kind of like how many layers you want the model to be offloading so that it can use it. And context size basically means how much approximate size you are thinking it will consist of, including your prompt, your JSON, telemetry, everything included. So I have given a size of 2048. There is like default size already, but for me the data was pretty small, so I narrowed it down, but you can continue with whatever you have. Next is putting up the prompt. So for the prompt, this was again something that took me some time to understand. So when I did a normal prompt, it couldn't recognize much of that prompt. I actually went to Gemini and I asked this, like, what should I do to make this thing work? And it suggested me to add all these tags, like starter header ID tag, and then EOT ID tag, all this in order for the local LLM to be able to understand our language. So I did that, and that actually worked. It was able to understand and it was able to interpret and return me whatever questions I was asking. So once I set out my requirements and made it in a certain format, and I made sure that it was in an understandable format, because again, what they mentioned is even for the input, right, like the telemetry that will be sending to the AI, it needs to be in more on the JSON or dictionary format. So I had to make sure that I made that in a proper way, and I made sure that everything was aligning. So after initializing and after creating the proper prompt, we are going to use the method ask stream for the prompt to be analyzed by the LLM. And once that is analyzed, it returns on a form of stream, so you have to listen to it. And once you have all the tokens ready, like, you can print out the output. So I've printed out the output according to the phase. I'll be showing you in a while how the app looks like for each phase, so that you can understand that it's able to analyze the data that we are putting in and it's able to return a proper output. If you want to understand how this project works, you can download the project. I will be providing the link in the description. Also, I've commented few things that will help you in logging the data and understanding the data. So I have commented the payload preview part, and I have commented the LLM output part. But when you're debugging, when you're trying to understand like how the app works, you can uncomment this and see the output and the input that we are providing. So let's get back to the app and understand how the app is working. System log date is basically the day you're logging the data. In a general app, you'll be using just the current date, but here, in order to test like the different phases, I had to make sure that I added system log as a separate section so that I can change the log date, and then accordingly the LLM will provide me the output. So as you can see, I have set out menstrual, like my last menstrual cycle date, and then I am just changing the log, and then I'm clearing the output and I'm running the analysis, and then as you can see it is showing menstrual. We are again going to clear out and select another date, and it's showing it's a follicular date or a follicular phase. And then again I am changing the date, and it is you have to make sure you clear the output, and when you run the analysis it's showing ovulatory phase and what you should be doing, like some analysis it will be providing. And then when we change the date again, it's going to show it's in a luteal phase. So as you can see, it is able to understand each and every phase, and it's able to bring back the data that we require. And then we have the menstrual phase, so that it will be showing now. Okay, so there you go, you have the menstrual phase. So as you can see, the app is working with the local LLM, but in order to make it work, you have to keep few things in mind, and I hope this project will help you in doing so. If you want to integrate local LLM into your app, this will be a good start for you. If this video has helped you, drop a like and leave a comment. And as you know, I am participating in the 90 days challenge, and for this week this is the video. So stay tuned for next week, and I'll see you in my next video. Bye.